Hey folks, how you doing? It's Don Grandt, CTC, Cutting Tool Counselor, here with another edition of In The Loupe TV, sponsored by Harvey Performance Company. Hey, thanks for joining us on this episode. This one's gonna be a lot of fun, but before we get started, folks, we hit over 5,000 subscribers. Makes me feel blessed that everybody enjoys watching these videos and hopefully is learning something. Thanks. If you haven't yet subscribed, join part of the cutting tool militia that is Harvey Performance. We appreciate that. Thanks, like, share, all that good stuff. This one I am extremely excited about. We're gonna twist this just a little bit. We're gonna even give more information than I probably have on some of my other videos. We're gonna talk about something called B.U.E. B.U.E. sounds like a funny word. Built up edge on cutting tools. This is very important and it's really detrimental to the life of your cutting tools. We're gonna talk about what materials are prone to B.U.E., built up edge. We're gonna talk about what causes the built up edge on those materials. And guess what? We're gonna close it out by telling you how to combat built up edge. Yeah, a solution, a video with a solution. That's what this one's all about. Hey, before we get started though, if you get a chance, what types of materials your shop is working on or what you're working on in the comments. I'd really like to see what kind of materials this audience is actually machining in their facilities. But before we get into this B.U.E., built up edge, let's do a short intro and let's dive right in. Well, hey folks, thanks for coming back on this episode. We are talking about B.U.E., built up edge, B.U.E., B.U.E., B.U.E. I'm gonna keep referring to this as B.U.E. It's called built up edge. And before we get started with how we prevent it, what materials actually cause it, and what are some of the solutions to stop it, let's just give a quick definition of what built up edge is. It's very common. So basically, built up edge is when you're actually cutting a material with an end mill, a drill, a reamer, an indexable tool. It applies to everything, all kinds of materials. The material that you're cutting wants to weld itself or stick to the cutting edge. It's a huge problem and it's very detrimental to finishes. It's very detrimental to tool life. And if we don't prevent it, we're gonna have a lot of problems. So just understand before we get started, built up edge is where the material that we are cutting wants to weld itself or stick to the original cutting edge of your tool and therefore kind of start building its own cutting edge that's not going to be very conducive to giving you a good part and good finish or long tool life. So that's what built up edge is. We're calling it B.U.E. for this episode. Okay, so what materials, you saw at the beginning of this, I asked everybody, what kind of materials are you dealing with in your shop? It's good to understand this. So what types of materials, because it is a little specific, built up edge to certain materials, are more prone to getting built up edge? Well, these are your ductile materials, your soft, your gummy materials, and I'm going to run through a few of them. Number one is aluminum, right? Aluminum, some of your 6000 series and stuff like that is going to be prone to built up edge. Your coppers, your 304 stainlesses when you start getting into steels, your nickels, your titaniums that aren't in the hardened state. The gummier, the more ductile the material is, the more it's going to be prone to sticking to the cutting edge. Think about that. I said gummy, ductile, softer. It's going to want to stick to the cutting edge. So look at those types of materials if you're running them to kind of run your process that we're going to run through today to say, hey, is built up edge a problem and how do I need to prevent this? Because I am running one of those materials that's a little bit softer, a little bit gummier, and it's going to be conducive to getting a little bit more built up edge than some of these other materials. So just keep that in mind as we walk through how we combat this. So how do you determine if you have a built up edge problem? Well, here's something I wanted to bring up to everybody, and this is the things that I have to do at the Spindle, which is why I teach you folks out there so you can learn the same stuff that I apply. So how do we know that built up edge is a problem? Built-up edge disguises itself, folks. It disguises itself. If you pull a tool out, it's very hard to tell if built-up edge was the issue. And you know what it disguises itself with? It disguises itself with a chipped up cutting edge. If you pull a tool out of the spindle and you look at that and it's got all chipping down the cutting edge, what do you think right away? You think that you're either feeding it too fast, you got too much vibration in your spindle, or something's not set up right. That's not always the case. You could be having built-up edge problems, and when that edge builds up so high, that material is going to flake off eventually of the cutting edge, and guess what it takes with you? Takes the cutting edge. It takes the cutting edge off. So if you wait with built-up edge till the end of life, you might not know that you actually have a built-up edge problem. The only way to determine if you have a built-up edge problem in your spindle, and let's say you're running one of these materials that is kind of prone to built-up edge, the thing that you want to do, and the things that I do, is you need to run for 5 minutes and pull that tool and look at it and see if it's starting to get built-up edge. If it's not, it's clean, put it back on the spindle. You need to run it again for another 5-10 minutes, look at it again. What you're trying to do is find out if there is a built-up edge problem before you run that tool to life and the whole cutting edge is chipped out. We do it all the time when we're not aware whether or not built-up edge is causing our cutting edge to chip. We have to do it. You have to do it in segments. Pull that tool out, look at it about every 5-10 minutes of life, and see if there's material starting to stick to the cutting edge. This way, at end of life, when it's chipped out, you'll know that built-up edge was a problem. So now let's talk about how do we fix that? How do we eliminate built-up edge at the spindle? So let's just talk about some of the features on the cutting tool, and this applies across all cutting tools, that does not help built-up edge or is more prone to get you more built-up edge. Number one is rake angles on the tool. Geometry on the tool really can either prevent or kind of bring in built-up edge. So when you're running these gummy materials and you don't want built-up edge, you got to look at the, I'll start by saying material-specific end mills, drills, cutting tools, always the best way to go because they're designed for the material. So material specific. But you're looking at rake angles. You got a shear sharp. If you get a blunt edge or a flat rake angle, you're going to get more built-up edge. Plowing's not good. Plowing's going to be conducive to built-up edge. Flute finish. What is that flute finish like? Built-up edge wants to stick to the material, right? It's not going to stick to the material if it's slicker than snot on a marble, right? If that is a really slick cutting edge, a slick flute, it's not going to stick to the material. Coatings. You have to have the right coatings for the right materials to build up that barrier that doesn't get that chemical reaction so that material welds to the cutting edge. So the right coating is very important to put on your cutting tools to reduce built-up edge. Coolant, lubricity, MQL, always go with a coolant, especially in aluminums and stuff like that. Make sure you're using coolant. Concentration is high enough, and if you add coolant in the right places and the right concentrations, it will help prevent built-up edge. So the first thing I would say to reduce built-up edge, before we get in what you can do at the spindle, and trust me, I got some tips here, stick around. Some good tips we're going to talk about here. So the best thing you can do is make sure you get material-specific end mills that has the right geometry that combats and stops the built-up edge from the beginning. But if you didn't get the right geometry, are there things that you can do at the spindle? We're going to talk about that next. So you would think right away, heat, right? If we have too much heat with the ductile material, that we are going to create built-up edge. Believe it or not, raising the surface foot, getting more heat into your cutting edge when you have built-up edge, softens the material, anneals the material, and lets it slide off the cutting edge. The danger zone with built-up edge is the middle surface foot. The lower, not productive. You don't want to be at the lower surface foot. The middle surface foot, where you're not at the right temperature with ductile materials, is where you're going to get that built-up edge. So what you need to do is bring your surface foot up, You anneal your chip, you get it softer. When you get it softer, it slides off of the cutting edge, and therefore you can eliminate built-up edge. So be mindful, don't bring the surface foot down, bring the surface foot up, and that's gonna help prevent built-up edge. Got a little example I'm gonna show you right now. So you might be saying to yourself, heat, how if I get it hotter, it's gonna weld to the cutting edge. Here's a perfect example, and I'm gonna give a shout out to a gentleman named Joel Radner. He's actually my boss, but a very smart, intelligent cutting tool guy. Said this is a perfect example of how to combat built-up edge. If we take a look at this piece of butter, butter is a perfect example, and it's a little bit colder, it's a little bit softer, and we take a knife, a butter knife like this. When I take the butter knife and I just put this in the butter and then pull the knife out, what happens? Now, the knife is cold, so what happens is that butter wants to stick to that cutting edge, or the knife in this case. That's kind of similar to what you're going to get if you don't have the right temperature. Now, let me take that same stick of butter, okay, and let me take this knife, let me heat up this knife a little bit. I'm going to put a little bit of flame on this. I'll kind of heat it up. I'll speed it up a little bit. Now, when I get the knife hot, and yeah, it's turning a little bit black. It's a thinner knife. When I get the knife hot, and now I put it in the butter and pull it out, what just happened? You see how the butter didn't weld itself to the knife because I put heat into the knife, put heat into the cutting edge. I made the material around it softer, therefore it did not stick to the knife. That's a great example, isn't it? Shout out Joel Radner again. That's a great example, and this is kind of what's happening when you're actually getting built-up edge. Bring the temperature up at the cutting edge, soften the material around it, let it flow off that butter knife, let it flow off that material, and you're gonna be in really good shape, and you're gonna help eliminate the built-up edge in all those materials. So folks, it's recap time. It's been a while since I've done that. So it's recap time. What we're talking about is we're talking about built-up edge. It's a big problem with cutting tools to not give you the tool life that you need. What materials have built-up edge? Well, it's your gummy materials, it's your ductile materials, it's your aluminums, your coppers, it's your 1018s, your medium carbons, your low carbons, it's your 300 series stainless, titaniums, nickel alloys in the softer state. That stuff wants to weld to the cutting edge. How do we prevent it? Well, number one, make sure you got the right geometry. Material specific is going to be designed to give you the right rake angles, the right coating, the right geometry. That's going to prevent built-up edge. If you still get built-up edge, what do? Well, we need to definitely bring the heat up at the cutting edge. Bring your surface foot up, plasticize that chip, get a little bit softer, let it roll off. Butter experiment. Let it roll off that cutting edge a little bit easier. You're gonna get less built-up edge. You're gonna be in good shape. Also, I didn't mention this before, don't rub your material. Make sure you make a big chip, let that cutting edge do what it needs to do, roll that chip, let it slide off the cutting edge, make sure the geometry, you have a nice flowing flute, and everything will come out good. This is how you prevent built-up edge. Would love to know how many people in the comments, if you can put it in the comments, run into built-up edge in your shop. Or maybe you don't run into built-up edge and you think it's something else. But let me know in the comments if you have experienced built-up edge and how you fix it in your shop. Well, folks, that's it. That's it for this one. Built-up edge. Hopefully you learned something. Again, I'm trying not to make these videos very long. That's why we'll keep them a little bit short. I appreciate it. Stick around for the next one. That would be great. I'm Don Grandt, cutting tool counselor. Just remember before we go, 3 guarantees in life, folks: death, taxes, and spring passes. Have a great rest of your week, folks.